Alright guys, so now we are going to check if an array is in sorted format or not by using recursion. So check if array is sorted using recursion. Right, so let's say I have an array as 1 2 3 4 5. So this is, let's say, my array 1 and another array 2 is, let's say, it is 1 2 4 5 6. Right, so no, let's make this 4 and let's make this one. So this is not sorted and this is sorted. This is sorted in ascending order and this is, that's not sorted. So we are going to check for this using recursion. So we have to find the base case. So base case is so what we can do is, we have an array and we can have a pointer. So we can check every pointer if it is equals to the last value. Right, so for that what we can do is, we can check if I means if the iterator which we have for all the array is equals to the length of the array. So if iterator, let's say I is the iterator, is greater than equals to the array dot length. So if it is equals to this, then we can simply return true. So if we reach this point, that means all of the iterations is all of the iteration is in the next order. So we can simply return it as true. And then what our relation is, so relation is here is for array 1, for the sorted array, we can say that, okay, 1 2 3 4 5 and 5. Okay. So for this we know that the current element, so I, if I we have let's take two iterator here. So we will have j, which will be equals to array 1 of 0 in the beginning, and I, which will be equals to array 1 of 1 in the beginning. So if if let's ij, okay, so if I is less than j, then we can return. So we can return, and what we are going to return, the recursion. So we have to return the same recursion. So we are going to, let's say, check sorted. So check sorted will be our number. So check sorted, and then we will have I, j and arr. So this will be the, so if this happens, then what we can do is, we can simply pass, okay, this should be the iterator also. So if I and j, we can simply increase the I and j every time. So we can check instead of this, we can simply check I. Yeah, so instead of taking I and j, we can simply just change this. So as you can see, you can change in between. You need to know what you are doing correctly, and if you know, if you have faith in recursion, which is called the leap of faith which you take when you do recursion. So that's what I'm doing here. So I'm going to use check sorted here again. So if this is true, then what I can do is, I can add I plus 1 is my next, and then j plus 1. So we get next to, and then arr 1. So array 1 is passed. So if I do this, then it is fine. Else okay. So okay, So else it returns false as it reaches as I think j reaches the array dot length, it becomes true. So I think this is the generalized relation only. So generalized relation, so this is my generalized relation, I don't need this. So I think if I code this, I think I can get the correct input. Okay, so yeah, let's check. So I'm into code now. Let's create a main method, static void main. So we have main method string args. Okay, now we need an array. So array input either we can take, or let's not take from the user. Let's create an array input, and this is a sorted array. And then we can use a boolean here. Boolean is sorted is equals to check sorted, and then we can pass 0 1 and then a. Yes, and now we have to create, so static will return boolean check sorted, right? So we'll take int I comma int j comma a, and then if j is greater than equals to a dot length, it's an array. Okay, it's showing me an error. Identified expected checks. Okay, yeah. Int a. So if j is less than equals to a or dot length, we simply return true. That means everything is sorted. Else what we can do is we can check if okay, a of I is less than a of j, and simply return check sorted for I plus 1, j plus 1 and a. So we will check for this, else return false. Let's see if this works. So if is sorted, then we can print. Okay, array is sorted, else we can print array is not sorted. Okay, let's see if this works. So I run this file. So array is sorted, yes. So we can see that our array currently is sorted. Let's put 4 here. Now let's check. So array is not sorted, so we are getting the required output which we wanted for this. So this is how you can check if the array you have is sorted or not. So I'll explain this again. So what happens here is, this is just 2 examples. So it's not I did took it just to create a base case and a generalized relation. So base case had that if my any one of my pointer goes till array length, goes till array length or goes above it, so I can just return true. That means what we are doing inside the method is correct. So don't go to the base case first, just look at this first. So this says that if ARR1 of I is less than ARR of 1 of j, so that means this is in ascending order. So it's checking if first and second the first and second index of array is less than, means first index is less than second index or not. And then if it is true, then we increase it. So we check if the second index is greater than third or not. So I plus 1 j plus 1, that's what it do for array 1. Yes, so this we do continuously. And if at any case if ARR of I is not less than ARR of j, that means we return false. That means the array is not sorted. And if we reach j is greater than equals to ARR, means the j is at the last position, so we do not need to check anything more, and we have a sorted array. Actually, we should check for j also, because we need to see if the last element is sorted or not. So what I'm saying is, let's just change this. So if it is 1, and let's put this as 1, let's see if it works for this or not. So the array is not sorted. Okay, so it's fine for that. So this is because if this is equals to, okay, so j is incrementing every time. So if the last increment happened, we already had checked 5, because I was at 4, and 5 was at, j was at 5, so it checks fine, and it give us array sorted. So this is for check sorted array using recursion. Thank you.